Okay, on P11, it says find inverse functions and relations. Let's remember just for a second what a function is. A function is your x's do not repeat function, or it passes the vertical line test. Now, what does that mean? Okay, vertical line test, remember, if you draw any vertical line, your graph, it only goes over your graph once at any vertical line. Okay, so right now, erase. Right now, this is a function. And here's your vertical lines right here, right? So this is also a function, but let's talk about the inverses, okay? So on inverses, remember there is an imaginary y equals x line. And if we fold that piece of paper on that red dotted line, then you would get something that looks like this. Okay, it just kind of turns it 90 degrees. So on that blue graph that I just drew, right here, all of those yellow lines are crossing the blue graph twice, which means, like right here, this is at 4, 4, and this is at 4, -4. So for this x, it gets two different y's, and if your x's don't repeat, then you can't have two different y's. So basically, the inverse for this graph is not a function. Okay, so the graph below shows a function. Is its inverse a function? This answer is no. The easiest way to kind of know that is if you have horizontal lines going in your original graph and it crosses more than once, then whenever we twist it, those horizontals are going to become verticals, and there you're going to cross it more than once, so it's going to be a no. On this graph, right there, so on this graph, if this point right now is at 0, 4, then its inverse is going to be at 4, 0. And so it's going to look something like this. Okay? And so if I draw vertical lines all along that, it will only cross that blue line once every single time. So this inverse is a function. Okay, we're going to find inverses. So if we find inverses, there's two or three steps. 1, switch x and y. What does that mean? Okay, it says find the inverse. So we're going to switch the x's and the y's. Everywhere there's a y, we're going to put an x, and everywhere there's an x, we're going to put a y. So we have x equals y plus 3. Step 2, solve for y. So how would I get y by itself? I would subtract 3. So y equals x minus 3. So x minus 3 goes in that box, and x minus 3 is the inverse of x plus 3. So anytime it says find the inverse, that's what we're going to do. We're going to do 2 steps. We're going to switch x and y. So x equals the cube root of y minus 3. And now we're going to get y by itself. Whenever we're solving, we always want to work from the outside in. So what's on the biggest outside is the cube root. So what undoes cube roots? Cubes. So if I cube the right side to get rid of the cube root, I have to cube the left side to keep it balanced. So x to the third, that 3 and that 3 take each other out. So y minus 3, we add 3, and x cubed equals, sorry, that's bad. Bad and wrong. X to the third plus 3 equals y. Okay, so on some of these, they're going to give you a little bit of trouble, but I'm going to try my hardest to explain it. But please ask me whenever we get into class if you need help with these, because I definitely understand why it could be difficult. It's going to take me just a little bit of time to explain it, but once I get there, hopefully you'll understand. Now, the domain, and you're like, oh my goodness, right? The domain. The domain on this list, on this problem, is all real numbers. Okay? The range is every y that is greater than or equal to -1. Now let me explain. Actually, that is not all real numbers, is it? X is greater than or equal to 0 is the domain. My bad. Now let me explain that. The domain is always your x, right? And here is your x right now. If I put -4 into x, and I try to take the square root of -4, what happens? I get an imaginary number. So what's the smallest number that I can put in there to be able to get a real number? And that answer is 0. So I can put 0 in, that's why it says equals 0, or any number bigger than 0 to be able to do the domain. Okay, now the range. If we were to graph this, if I put the smallest number in for x that I could get, if I put 0 in, the square root of 0 is 0 minus 1 would be -1. So if I put 0 in, I get -1 out. So 0, -1 is right there. And it's going to look like this. Okay? So the range, it talks about the y's. So the smallest y that it could ever be is -1. And then it just gets bigger and bigger and bigger. That's a lot of talk for not even doing a problem, right? I'll get back to that in just a second. So let's find the inverse, and that's what that says right up there. So to find the inverse, everywhere there's a y, we put an x. Everywhere there's an x, we put a y. And now we solve for y. We have to get rid of the 1. So we're going to add 1 to both sides. So x plus 1 equals the square root of y. To get y by itself, we have to square both sides. So the square and the square root undo each other. So inside the box, I don't think most of y'all are going to have trouble with that part of it. This is the part that you would have had trouble with. So back to the original part. If the domain is talking about, for the original one, if the domain is talking about the x's and the range is talking about the y's, if we're finding the inverse, then that stands for inverse, then the domain was the original y, and then the range is the original x. You don't really need to know anything about the range for the inverse, but because it's talking about x right here, we are going to put the range of the original function. So x is greater than or equal to -1. It's a lot of information, I know. I will try to do better on the next one that we have, which is this one right here. Okay, let's find the inverse first. So x equals the square root of y minus 5. Now on that last one, when we were doing it, the first thing I did is I added 1. The reason I added 1 is because -1 was on the outside of the square root. On this one, -5 is on the inside of the square root. So the first thing we're going to do on this one is square both sides. So x squared equals y minus 5. Solve for y. So x squared plus 5 equals y. X squared plus 5 equals y. Now, on the domain of the inverse, basically we're looking for the range of the original function. And the range, whenever we're talking about square roots, always comes from this number out here. It would be x equals the square root, y equals the square root of x minus h plus k. K is always the range of your original, so k is the domain of your inverse. So greater than or equal to 0 because there's not a number out there. Okay, find the inverse. So x equals y cubed plus 7. X minus 7 equals y cubed. And to get the cube away from the y, we're going to cube root the whole entire side. So the cube root of x minus 7. And the last one, find the inverse of this function. So we switch the x and the y. So y equals the cube root of y plus 8. How are we going to get y by itself? We subtract the 8. X minus 8 equals the cube root of y. How do we get y by itself? We cube this side and we cube that side. So x minus 8 cubed. So that's how we find inverses. Now we're going to be asked, I'm going to go by this pretty quick because I have 2 minutes left. Is the inverse a function? Basically, if your largest exponent is odd, if your largest exponent is odd, then it is a function. Okay? If it is even, then it's not a function. Okay? So your largest exponent is 1. So if I found the inverse, it would be a function. Your largest exponent is 2. So if I found the inverse, it would not be a function. Your cube root basically is an exponent, and it is odd. So if I found the inverse, it would be a function. That's a 1, so this is a yes. And that's a 3, so this would be a yes. Also, I think that is it. Yes. Ask questions if you need help. Bye.